Hi everyone, our lesson today is the chances of winning and losing the Pick 4 lottery in New Jersey, USA. This is the famous logo of the game, and let's start. We have 4 urns. Each urn contains 10 balls and they are numbered from 0 to 9. And we are going to withdraw according to the following rules. The first one, we are withdrawing only 1 ball from each urn. And the second rule, we are withdrawing these balls in order and we are writing their names also in order. So let's start. Let's assume we have withdrawn ball number 3 from the first urn, and then ball number 8 from the second, and number 5 from the third, and number 9 from the fourth. Now these 4 balls are going to form a sequence of 4 numbers, and these 4 numbers are going to be a ticket number. So all these balls are losing balls now, and these are the winning one. So now we have a question: how many tickets the lottery corporation can issue? So we write all these withdrawal in order because order is important. And for the withdrawal of first digit, we have 10 ways. For the withdrawal of the second digit, we have also 10 ways. And the reason why, because every 10 balls are put separately in each urn. So each urn will have again 10 balls to withdraw from, or 10 ways to withdraw that digit from. And for the withdrawal of the third digit, we have also 10 ways. And so for the withdrawal of the fourth digit, we have also 10 ways. Now, according to the multiplication principle, we can multiply all of them to know the number of all possible outcome, or the number of all possible ticket the lottery corporation can issue according to the previous rules. And they are 10,000 tickets. The number of winning tickets can also be known using the permutation formula under the following 2 conditions. The first condition, order is important. And the second condition, withdrawing is with replacement. So how do we know that withdrawing is with replacement? Because tickets such as 1122 has 2 repeated digits. So since repetition is possible, then this is equivalent to withdrawing with replacement. Actually, the problem of withdrawing from 4 different bins is equivalent to the problem of withdrawing from 1 bin with replacement. So now let's use the permutation formula with replacement. For n objects taken r at a time, we have here n is the number of objects in the set. So we have 10 balls numbered from 0 to 9, and their total number is 10, and r is the number of objects in the generated sequence. So how many numbers do we have? How many digits? We have 4. So r is equal to 4. And now we have permutation of 10 digits taken 4 at a time. So we substitute in this formula n and r. So permutation with replacement of 10 taken 4, and that is equal to 10 to the power of 4, and that is 10,000 tickets. So the question is, what is the probability of straight play? So straight play means winning a number in the exact order. So let's say we play we are going to play 0714. So if a person is going to win, he should win if the winning ticket has 0 as the first number, 7 as the second number, 1 as the third number, and 4 as the fourth number. So in such case we have only one choice, so the event has only one outcome, and all the possible outcomes are 10,000 tickets. So we divide the number of elements in the event over the number of elements in the sample space, and that is 1 out of 10,000. So if we play around 10,000 times the same numbers, we are expected to win once. So another question, what is the probability of winning a 4-digit number with all different digits matching in any order? So we may have, let's say, 1, 2, 3, 4, and we may win if the winning ticket is 2, 3, 4, and 1. So let's see. This is what they call a 24 box play. So if we pick 1, 2, 3, 4, we can win it in 24 ways. But how do we know it is a 24 ways? So if we check this sequence here, we found that there is no repetition of the digits. That means permutation without replacement. And the formula for that is, for order and replacement not allowed, is permutation of 4 digits taken 4 at a time, and that is equal to 4 factorial, which is equal to a 24 possible order of this sequence. So if the winning ticket is 2413 and we played, let's say, 1324, we can still win with this 24 box play. How many possible arrangement we can have of this ticket 1, 2, 3, 4? We can also get that from the following table. So the first digit can be withdrawn in 4 ways, and the second digit can be withdrawn in 3 ways, and the reason is no replacement. And the third digit can be withdrawn in 2 ways, and the fourth in 1 way only. So we multiply them together and we get it 24 ways. Now, what is the probability of this 24 box play? So the possible outcome of the event is 24 possible outcome divided by the number of elements in the sample space, which is 10,000, and we get around a chance in 417 trial. What is the probability of winning by box and straight play at the same time? So let's assume we are playing these 4 different digits as a straight play. These different digits can also be arranged in 24 ways using a box play. And now we have 2 events, the event B and the event C, and we need to win them both. So their intersection is going to give us only 1 element, and the probability is going to be 1 divided by all possible outcome, which is 10,000. Now the question is, what is the probability of winning by box or straight play? So it's either 1. So let's assume we are playing these 4 different digit numbers, and we can arrange them in 24 ways according to the box play. So we need to win either 1. So how many possibilities do we have here? We have 24, and there is 1 mutual element, so this element is not going to be counted twice. So we have virtually 24 elements. So probability is 24 divided by 10,000, and probability is 1 out of 417. So our odds is 1 in 417 trial. We can also use the formula of probability for the union of these two events, which is equal to the probability of the first one plus the second event minus their intersection. So what is the probability of straight play? It's 1 out of 10,000. Probability of box play, 24 over 10,000 minus the probability of their intersection. We have one mutual element, so minus 1 over 10,000, and that's going to give us also 1 over 417. Another question: what is the probability of winning a 4-digit number with 2 digits the same? So we have a ticket such as AACD, which means it could be like 7734 5567, whatever. And for such case, they call it a 12-way box. I do not call it a 12-way combination because this is 12-way permutation, but they can use it in general terms sometimes as 12-way combination. So in such case, if we have a ticket such as 0012, this ticket can be reordered in 12 ways. But how do we know that this ticket can be ordered in 12 ways? We can use the permutation formula with identical items. So the size of the sequence is 4, and we have 2 identical items, so permutation of the sequence 0012 is 4 factorial divided by 2 factorial, which is 12. So we have a 12 permutation of this sequence, which contain 2 identical items. So now what is the probability? So we have a 12 outcome of the event divided by 10,000, and that is going to be 1 out of 833. So the odds are 1 to 833. So if we try the same sequence around 833 times, we are expected to win once. Another question: what is the probability of winning a 4-digit number with 2 sets of digits the same, matching in any order? So here we have the ticket in the form of AABB, which could be 7755 1122, and they call that 6-way box, or we can call it 6-way permutation box, because if we have a ticket such as 1122, then we can permute it in 6 different ways. But how do we know that? We can apply the formula of permutation with identical items for a sequence of the form AABB. So the size of this sequence is 4, so here we have 4 factorial, and the size of the identical items here is 2. So we divide by 2 factorial, and we multiply by the size of the second set, which is also 2 factorial, and we get 6 possibilities or 6 outcomes. So now the probability of winning any 4-digit number with 2 sets of digits the same, matching in any order, we divide the number of possible outcomes for the 6-box play over 10,000, and we get a chance in 1667. Another question: what is the probability of winning a 4-digit number with 3 digits the same, such as AAB, matching in any order? So in such case, they call it a 4-way box, and the reason why, because if we have a ticket such as 1112, we can arrange it in order in 4 different ways. How do we know that? We use the permutation formula. 4 factorial divided by the number of 3 similar digits, which is 3, and we get 4. So now what is the probability? It is 4 divided by 10,000, which is 1 out of 2,500. Another question, what is the probability of winning 4 similar digit number? So we have a ticket with the form AAAA. So in such case, let's assume this ticket is 2222. So this ticket can be played only as a straight play, and the reason why, it cannot be permuted more than once only. So we have only one possible outcome of this event, and its probability is 1 divided by 10,000. Now what is the probability of a front pair, which means winning the first 2 numbers in the exact order selected? So let's assume that the winning ticket starts with these 2 digits 1 and 2. Any ticket with these 2 digits 1, 2 is going to be a winning ticket for the front pair case. We don't care what the last 2 digits are. They could be any number. They could be 57, 09, 99, whatever. So in such case, we have the first 2 digits fixed and the last 2 digits are different. So we can select the first digit in one way only and the second digit only in one way because they are already fixed. But the last 2 digits, each one can hold any number, which means it can be selected in 10 different ways each. So what is the number of all possible outcome of these winning tickets? It is 1 times 1 times 10 times 10, which is 100 ways. So we have 100 winning ticket in such case, and the probability is going to be 10 divided by 10,000, so it's 1 out of 100. Now what is the probability of back pair, which means winning the last 2 numbers in the exact order selected? So let's assume that the winning ticket end up with the 2 digits 1 and 2. It means any ticket which hold at the beginning any 2 different number and end up with 1 and 2 is a winning ticket. So the last 2 digits are fixed, so they can be chosen only in one way, and the first 2 digits here, they can be chosen 10 ways each. So in such case, we multiply all of them and we get 100 ways, so we have 100 winning ticket for the case of back pair play. And the probability is 10 divided by 10,000, which is 1 divided by 100. So our odds are 1 out of 100 trial. Now let us deal with the case of fireballs. We have drawn all these numbers from these 4 urns, and now we have a new urn for the fireballs, and from which we are going to withdraw the winning number of fireball. So let's assume we have withdrawn ball number 2, and we are going to place it near these winning numbers, and now we have 4 winning numbers with the winning fireball. Let us study the case of straight play with winning fireball. This fireball here can replace any of these winning numbers, and therefore we can produce more winning tickets. So we can replace 4 times and get 4 winning tickets. Each one results from replacing the winning number with the fireball here. So here we replace number 3 with the fireball 2 and we get this ticket, and we replace the second winning number, which is 8, by the fireball 2, and so on until we get 4 winning tickets. And these tickets are now winning under the case of straight play with fireball. while these 4 numbers are winning under the title of straight play only. We are going to replace this winning fireball here with an abstract ball, and we call it F. So now we have this F here. We can replace any winning numbers with this abstract ball, and we are going to use this technique to solve all cases of winning with fireball. We have to answer the question, what is the probability of straight play with fireball? So if we have this winning ticket here, what we can do, we can replace any of these winning digits with the letter F, or with the ball F, or with the number F, whatever, and we get here 4 possibilities for outcome of this event. And to get the probability, we divide 4 by 10,000, and we have a chance out of 2,500 trials to win. Now the question is, what is the probability of winning a 4-digit number with 3 digits the same, matching in any order with fireball? As we have seen before, this is the case of 4-box play, so we have 4 winning tickets. But for each winning ticket, we can replace each digit with a fireball. So for each winning ticket, we have 4 winning tickets with fireball. So for this ticket, we have 4 winning tickets, and for the second ticket, we also have 4. So now we have 4 times 4. We have 16 possible outcome of winning a 4-box play with a fireball, and the probability in such case is 16 divided by 10,000, which is 1 out of 625 chances. Now the other question, what is the probability of winning a 4-digit number with 2 sets of digits the same, matching in any order, but this time with fireball? We have seen this case before to be a 6-box play. We are not going to repeat it here. So we have 6 winning tickets, and in such case, when we add a fireball, we are going to generate an extra 4 winning tickets for each winning ticket in this 6-box play. So for the ticket 1122, we have 4 winning tickets. For 1212, we have also 4 winning tickets, and so on. So we have 6 times 4 here, and the probability is 24 divided by 10,000, which is equal to 1 out of 416 trials. Now the question, what is the probability of winning a 4-digit number with 2 digits the same, in any order with fireball this time? We have seen before that the case of 4-digit number with 2 digits the same to be the case of 12-box play. So we have here 12 winning tickets in all these orders, and for each winning ticket, if we include the fireball, we are going to get 4 winning tickets. So now the number of possible outcome is 12 times by 4, and in such case we are going to get the probability of 12 times 4 divided by 10,000, which is 1 chance out of 208 trials. But before we finish, let's assume that the fireball is equal to 1. So in such case, we are going to have 1123 here and 1123 here. But these are not counted as one possibility. They are counted as 2 possibilities, and the reason is this ticket is going to win for the first one and is going to win for the second one. So they are regarded as 2 winning tickets, not 1. Now, what is the probability of winning a 4-digit number with all different digits matching in any order with fireball? So we have seen that before. We have seen that the case of 4-digit number with all different digits the same played as box to be a 24-box play with 24 possibility here. And if we include the fireball, so for each ticket we are going to have 4 winning tickets, and in such case we multiply 24 by 4 to get all the number of possible outcome, and in such case the probability is going to be 24 times 4 divided by 10,000, which is a chance out of 104 trials. Now what is the probability of front pair, which means winning the first 2 numbers in the exact order selected, but now with fireball? We have seen before that the number of possible outcome is going to be 100, and for each winning ticket we have 4 winning tickets if we include the fireball. So we have 400 possible outcome of winning tickets, and the probability is going to be 400 divided by 10,000, which is 1 chance out of 25 trials. Another question: how many tickets with 4 different digits in the form of A, B, C, D can be issued in Big 4? So ticket such as 7259 has 4 different digits, but in this ticket there is no repetition of the digit, which means we have the case of no replacement, and it is ordered, so we can use permutation without replacement formula. So in such case we have 10 different objects numbered from 0 to 9, so n is equal to 10, and we are withdrawing 4 objects, which means r is equal to 4, and we can apply the formula of permutation of 10 digits taken 4 at a time, which is 10 times 9 times 8 times 7, which is 5040 tickets of this form can be issued by the corporation in Big 4. Or we can use a table of permutation. So here we have all the event of withdrawing the first digit, the second, the third, and the fourth. So withdrawing the first digit can happen in 10 ways, and the second digit in 9 ways, and the third digit in 8 ways, and the fourth digit in 7 ways. So according to the multiplication principle, the number of all possible tickets of the form A, B, C, D is again 5040 tickets. So now, how many tickets with at least 2 repeated digits can be issued in Big 4? So what are these tickets with at least 2 repeated digits? They are the tickets AABC, they have this form, or they have the form AABB, or AAAB, or the ticket with 4A. So all these tickets, they have at least 2 repeated digits. So how do you find their numbers? We subtract the number of tickets with 4 different digits from the total number of possible tickets, and we get 4960. And now we can summarize the result as follows. We have 5040 of tickets with different digits, and we have 4960 of tickets with at least 2 different digits, and these are all these tickets. Their sum is 4960. From the previous question, we noticed that we have partitioned the sample space of 10,000 tickets into 5 subgroups, and these 5 subgroups are: first one, the tickets with 4 different digits, and the second one, the tickets with 2 similar digits, and the third one, the tickets with 2 set of similar digits, and the fourth one, the tickets with 3 similar digits, and the last one, the tickets with 4 similar digits, and the total number of these tickets is 10,000. So we are going to represent the sample space using Venn diagram. So we have a sample space of 10,000 tickets, and inside of it we have two subgroups. The first one is a set of tickets with 4 different digits, and the second one, the set of tickets with at least 2 similar digits. And we have seen that the number of these tickets with 4 different digits is 5040, and the number of tickets with at least 2 similar digits is 4960. But inside this group also we have another 4 subgroups here, which is the ticket in the form AABC, AABB, and AAAC, and 4 A's here. And this is the first group here. So now we are interested in knowing the number of each subgroup here. This is what we don't know still. So this question is a bit difficult. How many tickets with 2 repeated digits A, B, C can be issued in peak 4? So let's start. The repeated digits can be 00, 11, 22 until 99. And this is the form we have. So we are now counting all the possibilities, and for each ticket like this we can permute these tickets in how many ways? In 4 factorial divided by 2 factorial. But the question is how many ways we can permute C and D. That's a very important question. So for a ticket such as 00, C and D, we can choose this first digit here from the group of 1 until 9. Why not from 0 until 9? Because if we chose C as 0, then we are going to have a ticket of the form 000D. So this is a ticket with 3 digits the same, and we are dealing with ticket with only 2 digits the same. So this is why C can be chosen in how many ways? In 9 ways only. How about D? D, if we let's assume that we chose C to be 1. So D cannot be 0, otherwise we'll have 0, 0, 0, and it cannot be 1, because otherwise we are going to have 0, 0, 1, 1, which is not the form AABC but the form AABB. So this is the first notice. Now the second important notice is that if we use permutation of CD and after that we permute 00 CD, we end up permuting CD twice, and that means that we are going to count the same element more than once, and this is not acceptable. So what do we do in such case? We use combination of CD. So combination does not imply order in it, and we have for CD we have 36 combination. So now after we combine CD 36 times, we can permute all this sequence how many times? 12 times, and the total number of outcomes for this sequence only is going to be 36 times 12. And for all these sequences, the possible, which are 10 sequences, the possible outcome is 36 times 12 times 10. And now we get the number which is 4320, and that is the number of ticket with 2 repeated digits in the form AA, B, C. And now we can summarize the results as follows. We have a group of tickets with 4 different digits. We know their number, and we have the tickets of 2 similar digits, and their number is 4320. And now we are going to look for the number of tickets of the form AABB and until the end. So this Now we are going to update our information that we have all these number of tickets is known to us, and we have 3 subgroups. Number of tickets we don't still know yet. Now if we want to make sure about the number of tickets of the format AABC, we can start with 2 identical numbers such as 0, 0 and find all their combination and then permute them. And again we do that for the 2 identical numbers such as 1, 1, and we do the same thing exactly, and then 2, 2 and then 3, 3 until 9, 9. So let's start now with 2 identical numbers such as 0, 0. So we have here in the first table 0, 0 with 1, and then 0, 0 with 2, and 0, 0 with 3, and we keep doing that until the last table. But we have to notice something very important, that we have similar combinations. We have 0, 0, 1, 2 and 0, 0, 2, 1, and when we start to permute, let's say this ticket and this ticket, we are going to get mutual element between them, so we are going to count the same element more than once. So for this reason we have to cross off all these highlighted tickets before we permute them, and we end up with these tickets. They are ready for permutation, and their number is, each table has, the first table has 8 tickets, and the second table has 7, the third has 6. We add them together and we get the total number of tickets for the case of 0, 0. How many ways of permutation can we get for a ticket such as 0, 0, 1, 2? It is 12 permutation. So now we multiply this number with 12 and we get all permutation of tickets for the case of 0, 0 tickets. So for the case of 0, 0 identical items ticket, the total number after permutation is 432. We can do the same thing. We can repeat the same process for the 2 identical items 1, 1, and we can eliminate all these combination which is similar to other combination here, and we are going to end up as we did before with these tickets, and we keep doing that until we arrive at 9, 9. So we have total number of identical repetition from 0, 0 to 1, 1 to 2, 2 until 9, 9. We have a total of 10 groups of table. So now if we want to find the total number of tickets, we have to multiply the total number of rows for each identical group times 12, which is permutation for each row, times the number of table sets, which is 10, and we get again 4320. And that is exactly similar to what we did before. We multiplied combination 9, 2 times 12 times 10, and we got 4320 ticket of that form AABC. Now the question is, what is the number of tickets with 2 sets of digits the same, such as AABB? So to do that, we start with 2 identical items 0, 0, and we combine them with the rest of the identical items, which is 1, 1, 2, 2 until 9, 9, and then we start with the 2 identical items 1, 1, and we combine them with the rest, and we end with 2 identical items, which is 9, 9, and we combine them with the rest. So here we have conducted this combination, and before we permute anything, we have to eliminate any similar combination. Otherwise, we are going to count the ticket more than once. So we continue until the end and we cross off all these highlighted tickets. We cross it off and we end up with this set of tables. So the number of tickets in all these tables times the permutation. So we can permute any ticket with the form 0011 or the ticket in the form AABB. We can permute it in 6 ways, and the total number of tickets in the previous set of table is this sum here from 9 until 1 times 6, the number of permutation, and we get 270 tickets of the form A, A, B, and B. So now we can come back to the diagram of sets and we can add that the ticket in the form A, A, B, B, their number is 270. Now the question is, what is the number of tickets with 3 similar digits in the form AAAB? So let's start combining 3 similar digits from 0. So we start with 0, 0, 0 with the rest of the numbers except 0, because if we include 0 here we are going to get a ticket with 4 similar digits, and then 1, 1 with the rest of the numbers, and 9, 9 with the rest of all the digits. And what do we get? We get all these tables here, and each table contains all these tickets, and each ticket can be permuted in how many ways? Can be permuted in 4 ways. So each table contains 9 tickets, and each ticket can be permuted in 4 ways. So we are going to get 9 times 4, which is the number of permutation per one table, and we have 10 tables. So 9 times 4 times 10, we end up with 360 tickets in the form of AAAB. Now we can add to our subgroup the number 360 for the tickets in the form AAAC. Now what is the number of tickets with 4 similar digits such as AAAH? So this is very easy to be found. They are 10 tickets. So now we can find the last unknown in this subgroup, which is 10 here. And now everything is known, and we can find the probability of this event, which is more probable and which is less probable. Now we have the question, what is the sum of all tickets? It should be 10,000 because they are disjoint set. So we add them together and we get 10,000 exactly. So we are going to summarize all of these sets in this table here. A set of ticket of different digits, set of ticket of 2 digits similar, set of ticket of 2 groups of digits the same, set of tickets of 3 digits similar, and set of tickets of 4 digits similar, and their corresponding number here, and their sum is 10,000. Now the question is, what is the probability of these events? This is easy to be done now. We can divide the number of tickets by 10,000 and we get all corresponding probabilities here. Another question, what is the probability of these events in descending order? So we realize here that these 2 events are not in order, so we swap them and we get everything here in order. So now the last question is, what is the meaning of these probabilities? If we run this experiment around 1000 times, we expect to get 504 tickets of different digits, 432 tickets of 2 similar digits, 36 tickets of 3 similar digits, and 27 tickets of 2 groups of similar digits, and only 1 ticket of 4 similar digits. We can find from this group that the 2 events that are most likely to happen are the event where the tickets are of different digits and the ticket of 2 similar digits. The rest of these events are less likely to happen, and the least likely to happen is the ticket of 4 similar digits. We can also conclude that from the history of winning numbers of this game for each game. And that's it for today. Thank you for listening and have a good day.